All right, let's look at this. Check your understanding. So write the event that a student has seen 3 Home Alone movies using probability notation, and then find this probability. So probability of X equals 3. We actually didn't have that on our table. But what do we know about probability models? All adds up to 1. So I added up the numbers that they gave me and I subtracted that from 1 to find the probability, and I came up with 0.08. What does the probability X greater than or equal to 3 mean? Yes, the probability that a student has seen 3 or more of the Home Alone movies. What is that probability? 0.11. Yep. And then they asked us to make a histogram of the probability distribution and to describe its shape. So my histogram looked like this right here. The distribution of Home Alone movies watched by a very large sample of high school students is skewed right. You see that tail off to the right, with no outliers. The center appears to be between 1 and 2 movies watched. It's unimodal. It has 1 mode. The mode is at 1, so you could say it appears to be around 1. The range is 5 movies watched. Remember, to find the range, you take the largest reported value and you subtract the smallest reported value. And the smallest reported value in this case was 0. And then we're going to use this last piece as soon as we get started here today. Calculate and interpret the expected value of X. This is a weighted average. If I just take those values for X, 1 through 5, and add them up and divide, is that going to give me the correct average for this group? No. We need to multiply it by the probabilities for each of those values so that we end up with our weighted average here. So it would look kind of like this. You should get 1.43. That actually matches what we said up above, or what I said up above, where I expected the center to be somewhere between 1 and 2. You almost can't get closer to exactly between 1 and 2. And then the interpretation of that, if many, many, many students are randomly selected, the average number of Home Alone movies they have seen is about 1.43. All right. As soon as you are done getting this down onto your page, go ahead and flip over to page 5 then. All right, I'm going to come around and ask you what number you got on your little card. So if you haven't looked at it yet, go ahead and flip it over. All right, we have 7 and a 10. Dylan, do you mind flipping yours over for me? Another 10, awesome. Joan got a 1. You could flip yours over, thank you. We have another 10, 15, 7. You had a 10. Max, what did you have? You had a 7. Right, Tamia, you had a 5. Yeah. Grayson, you had a 7. And another 10, another 10, and another 5. Okay. All right. So suppose you get a new job and each day your boss draws a slip of paper from a bag. In this case, I walked around and asked you to pick a card to determine your wage for the day. Let the random variable X mean the daily wage or the dollars per hour. So I want you to write in what you got on your little cards that we can remember for later, because we're going to use this again a couple more times. So write in your amount. On mine, when I drew the card, I got a 10. All right, and then, oh, I hate when it does that. Sorry, guys. Doing our probabilities. So I took a card as well, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus me makes 15. So all of our probabilities here are going to be out of 15. One person got $1. So we've got a 1 out of 15 here. We had 2 people get $5 an hour, so 2 out of 15. $7 an hour, we had 4 people, so 4 out of 15. For 10, we had 7 people get that. So 7 out of 15. Nobody got $15 an hour. Oh, sorry, one person got $15 an hour. My apologies. One person got $15 an hour. Nobody, however, got the 25. It's still somewhere in my cards over here. I want you guys now to calculate and interpret the expected value of X. So this is very similar to that last question that was on the check your understanding. Calculate and interpret the expected value of X. Thank you. Thank you. Thank you. All right, somebody tell me if I got my probabilities correctly matched with those dollar values. Did I get that right? I was going off of memory here. All right, so again, we multiply the dollar amounts with the probability to calculate our expected value. What did you guys get for our expected value? 8.26. Is that what other people got? Okay. What does that mean then? Because they asked us to interpret this as well. What would this mean?
Average wage per day.
Yep, if we draw many, many, many wages out of this hat, where these are the possible amounts, the average wage is going to be about $8.26 an hour. Please make sure that you're getting that many, many part on there, because that is actually important. If we draw many, many, many wages, the average wage is about $8.26 an hour. All right. Do you guys remember all the way back in chapter 1, so we're reaching all the way back to August now, when we calculated the standard deviation, it tells us the typical distance that any randomly selected point will be away from the mean. So I want to calculate this table. I want to compute the values on this table. So how far away is 1 from the mean? How would I calculate its distance? Subtract. So 1 minus 8.26. Negative, I'm sorry, how much? So we do 1 minus negative 7.26. Yes, I want you guys to do that for the remainder of these values here. So distance from the mean is value minus the mean, which in this case is 8.26. So calculate that the rest of the way down here. After you've done that, I want you to square all of those numbers. So after you've calculated their distance away from the mean, so everything in that column that we just wrote these numbers in, I want you to square all of those values. Go ahead and just round it to 2 decimal places if you're getting longer numbers. Remember, when you square those numbers that are negative in your calculator, either pop parentheses around them or just remember that when you square a negative value, you should be getting a positive number. You're not going to have any negative numbers down this squared column. Double check yours against mine to see if you got the same values that I did. For this very last column over here, it says the weighted distance from the mean squared. The way we weighted our expected value was by multiplying those values by the probability that it occurred. So we're going to do the same type of thing here. We're going to take our distance from the mean and we're going to multiply it by the probability that that value happened. What was the probability that somebody got a 1 here? 1 out of 15. So I'm going to take this 5271 and I'm going to multiply it by 1 out of 15 to get this value. What would I multiply the next one by? 2 out of 15. So go ahead and calculate those all the way down. And then I want you to add them up and write that where it says total. You're just going to total up that very last column. Does anybody remember how to take this total now and find our standard deviation from that? What did we do to make sure that everything came out positive? Squared it. So what would I need to do to kind of undo that process at the end? Square root it, yes. So this total right here, this is called my variance. And it is equal to the standard deviation squared. For my standard deviation, I just want sigma. So I want to take that number and I want to square root it, 9.798. What are we getting? Bigger or smaller than 5? Smaller. Bigger or smaller than 4? Smaller, bigger or smaller than 3? Bigger, so 3 point what? 3.13, and since it's got a 0 after that, I'm fine with just leaving it right here. So here's our standard deviation, here's sigma. How would we interpret that? What does that mean? Yes, the average distance from the mean. So as I go around this room and everybody drew a card, remember we said our average wage was about $8.26 an hour. And so on average, I would expect most people in the room to be within $3 of that. So anywhere between what, 5-ish and 11, 12. Most people, not everybody, but that would grab most people in the room. And that would be one standard deviation away from the mean. Right, so the wages typically vary by $3.13 from the mean of $8.26 an hour. The wages typically vary by about $3.13 from the average of $8.26 an hour. So this is the same thing as saying this is the average distance away from the mean, but we've worked our context into it. So typically, any random person in here that I would select, their wages are going to be different from the mean by about 313. So the formula that we used to calculate our standard deviation, I do want you guys to get this written down just so that it's not totally unfamiliar with you. But then I want to make sure that we know what all the pieces mean, because we did it over here and the process itself isn't necessarily difficult. We're going to learn how to use the calculator to do that for us in the future, but I want to make sure that we know what all those parts mean so that we know that we have the calculator doing the right thing. So our standard deviation, sigma, is equal to the square root. Now I want you to tell me, from left to right in this table, what did we do? What did we start off doing? From left to right. So what did we start off doing in this column? Yep, we subtracted from our expected, or we subtracted our expected value. So I'm going to call each of those x's xi. And then we took each of those numbers and did what to it? Before we square rooted, what did we do here? We squared them. Square rooting is what we did all the way down at the bottom here at the end. So we took all of those expected values, or all of those values minus the expected value, we squared it, and then what did we do? We multiplied by the probability, by each individual probability. So I'm going to call that P, and then with that little I. And then what did I do with all of these numbers over here? We added them all up. So we use that weird E looking thing to say that we added them all up. And only after we added them all up did we square root them. So this is the sum. Each X value minus the mean, then squared, multiplied by each probability. We'll use the lists in your calculator to make the calculator do this so that we're not doing it by hand in table form each time, since the calculator can do those computations much faster. But we're going to set up tables in the calculator to basically do this right here. We'll use those lists to do this. So far, so good? All right. What about if your boss decided, instead of drawing cards for the wages, she wants to set it so that employees could get any amount from $10 to $20, and all of them are equally likely? What would this look like? If I asked you to draw a picture, what would I need to make sure to have along my x-axis? What are the values for X? What are the values for the wages that I would need to make sure are on my x-axis? 10 to 20. And if they're all equally likely, would it have a histogram that looks like this? What would it look like if they were all equally likely? It's going to look flat. This is called a uniform distribution. How many dollars are in between 10 and 20? 10. And so we do 1 over that value. So this is what this would look like. Anywhere between 10 and 20, that would be my wage. And the probability of all of those would be equally likely, so 1/10. This is called a uniform distribution. And the way I get this over here, I do 20 minus 10. That's where that 10 came up with, or that's where I came up with that 10. And then it's going to be 1 over that amount. Since it is uniform, all of them will have the same probabilities. What would the probability be that an employee makes somewhere between 12 and 1250? How would I calculate that? Somewhere between 12 and 1250. What's the chance that they make exactly 12? 1 out of 10. What's the chance that they make $12.15 an hour? 1 out of 10. What about 12.25? 1 out of 10. So what we're going to do here to find the full probability that it's anywhere between 12 and 1250, we're going to find the area in that section. Since all of them are 1 out of 10, if I had this, and that's 12, 1250 is right here. We're going to find this area, and that will give me the probability. Because just like a standard normal distribution, if all of my probabilities here are 1/10, the area underneath that rectangle is exactly 1. So how do I find the area of that rectangle? That's going to be length times width, right? How wide are we across the bottom? From 12 to 1250. How far is that? 0.5, yeah. 1250 minus 12. So I get 0.50. 0.50 would be like my length. Times my height. How tall is that? 1/10. Multiply those together. So 0. What? 0.05. If you were to tell me that as a percent, what's the probability as a percent that an employee makes somewhere between 12 and 1250? 5%. 5% probability that they make between 12 and 1250. All right. Big ideas for today. When I had us pull the wages out of the hat, would that be discrete or continuous? Is that more like shoe sizes where like you get what you get and you can't get anything in between? When I had you pull the cards? Could you get paid $8.26 an hour even though that was our average? Do you think that was a value that I had on any of these cards? No. The values that I had on the cards matched what we had in the table. I had 1, 5, 7, 10, 15, and 25 written on the cards. That would be discrete data. What about in this uniform distribution? Could somebody make 1236? What about 1508? 1509? 1510? That's an example of continuous. We can take all the values in between. So continuous random variables usually get described in one of two ways when we're talking about probabilities, when we're talking about statistics. We've got our uniform that we just practiced, and then the normal. We went over that on our virtual day, and then we went over that at the beginning of class yesterday. The check your understanding is talking about normal. We're going to have to start class tomorrow with that particular piece. And I'll go over how to put stuff in the calculator again right at the beginning of class tomorrow. Standard deviation for discrete. This would be if it can only take specific values and you can't have the ones in between. So number of kids in your family, shoe size. When I had you guys pull the wages from a hat, those can only take on very specific values and it can't take on the values in between. If you get all of this into your notes and you want to get started on the check your understanding, go for it. We're not going to go over it until the beginning of class tomorrow, though.
All right.
First homework is due tomorrow night. I will go over one more time tomorrow how to put things for normal distributions into your calculator. If you guys have any other questions about the homework, please bring them to class tomorrow so that you guys can get that finished up. I will give you your next homework assignment tomorrow as well. And we will start digging into 6.2 tomorrow. Have a fantastic rest of your day, guys.